Hello guys, welcome to the lesson. Today's topic is trigonometric ratios in special triangles. From the previous week, you should know the rule of Sohcahtoa, which is sine opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and cotangent adjacent over opposite. Okay, tangent and cotangent, they are vice versa, yeah? And so one thing to mention about this rule, that these sides, opposite and adjacent sides, they all depend on the angle that we're looking at. For example, for alpha, sine alpha, opposite is this side, adjacent is this side, but for angle beta, adjacent would be this side, yeah, and the opposite side would be this side. So don't forget about the angle. So according to the angle, you will make a choice which is adjacent and which is opposite side. So let's move to the practice problem. So you have a triangle, a right triangle. Okay, so this is very important that you only deal with right triangles. Okay, so you have a triangle, right triangle. The hypotenuse is 3, and again you have this alpha angle here, and the one leg is 2. So you have to find what is sine alpha, what is cosine alpha, what is tangent, and what is cotangent alpha. Okay, so to find this one, we have to know all the sides. Yeah, but we don't know this one. This is x, so we can find this one using Pythagoras theorem. So which is 2 square plus x square equal to 3 square. Okay, then you have 4 x square 9, so x square equal to 5. So here x would be equal to plus minus square root of 5, but since this is the distance, yeah, this is the length, we only take plus positive one, because there is no like negative length. Okay, so you know x, yeah, so x is square root of 5. So what is sine alpha? Sine alpha, we know it is opposite over hypotenuse. So opposite to alpha, it is square root of 5 over 2. Yeah, hypotenuse is 3. Okay, cosine alpha, what is cosine alpha? It is adjacent over hypotenuse. Adjacent is 2, hypotenuse is 3. Yeah? So tangent alpha, so tangent, as we know, opposite over adjacent, so root 5 over 2, and cotangent, it is adjacent over hypotenuse. Yeah, adjacent over opposite, so adjacent over opposite. So make sure here you have to that you should rationalize this fraction. You don't leave the denominator in the rational form. So you have to multiply by root 5 each in numerator and the denominator. Then you get here 2 root 5. Here you get just 5, yeah, because square root of 25 it is 5. So that's it. So okay. Let me give you another example. So if you look to the problem A, you have tangent alpha equal to 4, and you have to find the sine alpha, cosine alpha, and cotangent alpha. So so let's say you have some right triangle, and you can locate alpha to any of the angles. It doesn't matter. Okay, let's put it here. Yeah. So it says tangent alpha equal to 4. What does it mean? So which is opposite? We know this is opposite over adjacent, yeah? So which is opposite? So 4, you can write it in fraction 4 over 1. So opposite would be 4 and the adjacent would be 1. So now you have to just find the hypotenuse, yeah? So let's say hypotenuse is x. So according to the Pythagoras theorem, 4 squared plus 1 squared x squared, it's equal to 17 x squared. So x is equal to square root of 17. So please don't forget that when you have square, you always have two answers, but you take just plus 1 because the distance cannot be minus. So you have this one is square root 17, yeah? So what is sine alpha? So sine alpha is opposite over hypotenuse, which is 4, yeah? So according to this side, it is this one is opposite. So 4 over root 17, square root 17. So here you have to also rationalize this one, and to rationalize you have to multiply by square root 17. So then you have here 4 times square root 17, and here you get just 17, yeah? So, cosine alpha would be adjacent. For alpha, adjacent is this side, yeah, which is 1. So 1 over square root 17. So you have to also rationalize these two, and then you get square root 17 over just 17, and cotangent would be equal to adjacent, yeah, adjacent over opposite. So adjacent is 1 and opposite is 4. That's it. Okay, let's go to second example. So here you have beta, cosine beta is equal to 2 over 5, yeah? So let's make some right triangle. So let's make beta, so it doesn't matter, let's put it here. So here, this is important, how you locate. So if you put beta here, the hypotenuse would be, so cosine beta, yeah, it is adjacent over hypotenuse, so which is 2, 5. So according to beta, so you put beta here, so adjacent, so 2 should be here, and the 5 would be here. So you have to find x, yeah? So what is x? 2 squared plus x squared, 25. Then it will be x squared 21, and x would be square root 21. So this one square root 21. So sine beta would be equal to opposite, yeah? This one for beta, the opposite side is this one, square root 21 over 5. Cosine beta, you know it. Get tangent beta, opposite over adjacent, it will be opposite 21, square root 21 opposite, and the adjacent is 2 here, yeah, for beta it's 2, and the cotangent, it will be adjacent 2 over square root 21. And now you have to rationalize it, which will be 2 times square root 21 over just 21. So this is your answer.